it's time to show a proof of the theorem that states that the sum of the measures of the three angles of a triangle is 180 degrees, which is also known as the triangle sum theorem. Let's start with a triangle ABC. And then we're trying to prove that the three angles add up to 180 degrees, as shown. The parallel postulate allows us to draw a line through B that is parallel to side AC of our triangle. And then we can show three angles at the top that are adjacent and form a straight line, and we're labeling them angles 1, 2, and 3. And we can now see that the angles marked in red, angle 3 and angle A, are alternate interior angles, so they're congruent. And the two angles marked in blue, angle 1 and angle C, are congruent because they're also alternate interior angles. And then the three adjacent angles, 1, 2, and 3, form a straight line, so their sum must be 180 degrees. And then we can simply substitute angle A for angle 3 and angle C for angle 1, and of course our original angle B is the same as angle 2, so by substitution we've now shown that the three angles of the triangle must add up to 180 degrees. And now another theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. We already had a proof that the measure of an exterior angle is greater than either of the remote interior angles, and now we're going to prove that it's equal to the sum of those two angles. Once again, we start with a triangle, and we'll extend one of the three sides to show one of the exterior angles, and we're going to mark that exterior angle, angle 1. And our job is to prove that the measure of angle 1 is equal to the sum of the measures of angle A and angle B. We know that the measure of angle A plus the measure of angle B plus the measure of angle C is 180 by the previous theorem, the triangle sum theorem. We also know that the measure of angle 1 and the measure of angle C is 180 because they form a linear pair. And now we substitute, since the measure of the three angles of the triangle equal 180, and the measure of angle 1 plus the measure of angle C equals 180, then those two expressions, since they both equal 180, they equal one another, as written here in our last line. Then we can subtract the measure of angle C from both sides of our equation, and we get what we were trying to prove, that the measure of angle B plus the measure of angle A is equal to the measure of angle 1, or in other words, the sum of the measures of the two remote interior angles is equal to the measure of the exterior angle at the other vertex. And now another theorem. A segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is 1/2 of the third side. This theorem is called the midline theorem. We start with a triangle. We find the midpoints of two of the sides. We connect those midpoints to form a segment. And what we're going to prove is that the new segment DE is parallel to the third side, AC, and that it's half the length of that third side, or 1/2 DE is equal to AC. We're allowed to extend our segment DE so that E is the midpoint of DF. And then we're going to mark the segments that we know to be congruent. The segments that have a single tick mark are congruent because D is the midpoint of segment AB. The segments that have a double tick mark are congruent because E is the midpoint of side BC. And the segments that have three tick points are congruent because we extended segment DE all the way to F such that E was the midpoint of DF. And now we can connect points F to C because 2 points determine a line. And we have two triangles congruent by side angle side. And then by corresponding parts, we can now mark that DB and CF are congruent, and a pair of angles BDE and EFC are also congruent, and they're shown with a blue arc each. The two angles marked with blue arcs are alternate interior angles relative to segments AB and CF, and therefore we know that those two segments are parallel. And since CF was congruent to DB and DB was already congruent to AD, we now know that CF and AD are congruent. So what we have now is a parallelogram, ADFC, and the reason we know it's a parallelogram is because the opposite sides AD and CF are both parallel and congruent. And since it's a parallelogram, we now know that DF is parallel to AC. And that's one of the things we were trying to prove, because segment DE is part of segment DF. So if DF is parallel to AC, we also know that DE is parallel to AC. And we have one last thing to prove, that the segment DE is half of the segment AC. And that doesn't take long. DF and AC are congruent because they're opposite sides of a parallelogram. And since E is the midpoint, we know that DE is half of DF. And then by substitution, we can replace DF with AC, and we've proven what we needed to prove, that that segment that connects in the midpoints, DE, is half of the third side of the triangle, AC, and it's parallel to that side. In this lesson, we looked at three theorems. Theorem 50, the triangle sum theorem. Theorem 51, the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. In Theorem 52, the midline theorem, a segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is 1/2 the length of the third side.